Okay, this is section 4.6, completing the square. Actually, the quadratic formula and the discriminant. All right, so we're going to, the vocabulary we need to be familiar with is the quadratic formula, the discriminant, and the radicand. Our objectives are to solve quadratic equations by using the quadratic formula, and we're going to use the discriminant to determine the number and types of roots of a quadratic equation. So let's go back to what a quadratic formula is. It's simply a formula. So write this down. It's negative b plus or minus the square root of b squared minus 4ac over 2a. That's all it simply is. So in order to utilize our quadratic formula, the first thing we have to do, we're going to take our first example. We've got to put it in standard form. So we're going to look at example 1 on page 265. And it's simply x squared minus 10x equal 11. So I said the first thing we have to do is put it in standard form. So I'm going to minus 11 from both sides. And I get x squared minus 10x minus 11 equals 0. Then I have to identify what is a, b, and c. Remember, those are the coefficients of the, a is a coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant. So a is 1, b is negative 10, c is negative 11. So we use the quadratic formula when we're unable to factor or we don't want to complete the square. So let's go ahead and do it. So we're going to start with negative b, and what is b? Negative 10 plus or minus the square root of negative 10 squared minus 4 times a times c all over 2 times a. So opposite of a negative, or a negative times a negative, is 10 plus or minus square root of negative 10 squared is 100 plus 4, because I have a negative times a negative, all over 2. Then I can simplify this to say, this is 11. I have to write this correctly. So it's 44. And I get 10 plus or minus the square root of 144 over 2, or simply 10 plus or minus 12 over 2. And we said 10 plus 12 over 2 is going to be 11. 10 minus 12 over 2 is going to be negative 1. And those are my roots and solutions. And how do I check it? I put it back into my function to make sure I get 0, because y has to equal 0. That's pretty simple, right to the formula. Let's try one more example. So we're going to do x squared plus 8x plus 6 equals 0. Is it in standard form? Yes. A is 1, b is 8, and c is 6. So I'm going to say negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 6 all over 2. And I'm going to get negative 8 plus or minus 64 minus 24 over 2, negative 8 plus or minus the square root of 40 all over 2. And then we can simply just simplify that. Oh, this is 16, excuse me. This is 16, and 16 times 4 is 64. So I actually get 0 inside of here. And then, so you have negative 8 plus or minus 0, right? Plus or minus 0 over 2, which you should get negative 8, you get negative 4. Both ways you get negative 4. So we just write it once. We only have one solution, therefore it only crosses or touches, it touches at negative 4. There's only one root to this solution. Now, what if we look, what is a radicand? Remember, the radicand is the number under a radical sign. So 3 would be the radicand in here. So if we look at the quadratic formula, under the radicand is b squared minus 4ac. If it is less than 0, meaning it is a negative, we're going to get, the solution will be complex because basically we're taking the square root of a negative number. So we're going to have I. And when you have a complex number, they always appear in pairs. So what do I mean by that? Let's look at one. So if we take the example, x squared minus 6x equal negative 10. So I'm going to put this in standard form. And I'm going to take a is 1, b is negative 6, c is 10. So I'm going to do negative 6 plus or minus negative 6 squared minus 4 times 1 times c all over 2. So I get 6 plus or minus the square root of 36 minus 40 over 2, and I get 6 plus or minus the square root of negative 4 over 2, which is 6 plus or minus 4i. We just finished learning how to do that. Or 2, because the square root of 4 is 2. And then we have 6, so we can simplify 2, and we get 3 plus or minus I. And you see that we have a pair of conjugates, 3 plus I and 3 minus I. And then we can put it back in to check our solution. Okay, we talked about the radicand of a quadratic formula. The radicand is what's under the radical sign, which we said it's b squared minus 4ac. Well, this by itself, we call it the determinant. You've heard this word before. Okay, the determinant, or I'm sorry, not the determinant, excuse me, the discriminant. And the discriminant gives us information about the types of solutions and how many solutions. So if we just look at this, and you turn to page 268, you will see the chart. So if it's greater than 0, we're going to have 2 real solutions. Okay, and they can be rational or irrational. If it's less than 0 or equal to 0, then we're going to have 1 real solution. Okay, and if we have less than 0, meaning it's negative, it's going to be under the radical sign, we're going to have 2 complex roots. Or we can say no real solution. So let's look at that and use our discriminant to figure out what types of solutions we're going to have. We're going to look at example 5. So we do 7x squared minus 11x plus 5. They want us to find the value of the discriminant for each quadratic equation, then describe the number of and types of roots. So we know we're only going to do b squared, so negative 11 squared minus 4 times a times c. We're going to get 121 minus 140, which gives us negative 19. Because it's less than 0, it's negative, we're going to have 2 complex roots or no real solutions. And this is the discriminant, and this is the types of solutions. Let's try another one. X squared plus 22x plus 121 equals 0. All right, so I'm going to have 22 squared minus 4 times 1 times c, 121. So we're going to get 484 minus 484, so we're going to get 0. 0 tells us we have 1 real solution. All right, so you try this on your own, and you need to do problem number 2, lesson 269, page 269.